Hello student, welcome back. I am Professor Pratik Sathav from Savitribai College of Engineering, Pune. Today we have to discuss about the transformation in CAD-CAM subject. Transformation. In last lecture we have discussed of transformation, basic concept of transformation. Now we have to study of formulation in transformation. Formulation. Okay. In any two-dimensional space. Okay. In any two-dimensional space, we have here in image there have one 2D space in which point P is the coordinate of xy and it is transformed to point P dash is a x dash y dash. Okay. Two-dimensional space 2D, point P having x comma y, its coordinates of point P is transferred to point P dash, coordinates is x dash y dash. Okay. P is the original point, it is shifted or transformed to new location. P dash is the x dash y dash. Then if you write a P in matrix formation, then it's a P is equal to x y. Okay. And P dash, then it's a x dash y dash. For finding the new coordinates of P, means finding the new coordinates of P dash, you require to formula, and for that formula you have to formulate this. Formulation means you can find out the formula for calculating the coordinates of P dash is a x dash y dash. If we consider point P is shifted in x direction by Tx, okay, in x direction by Tx, and in y direction it's Ty, okay. In x direction is a Tx, in y direction it's a Ty, okay. It's a shifting of that point. Okay, then Tx and Ty included. Tx in x direction, in y direction is the Ty. It's called a transformation matrix. It's called a transformation matrix. Then for finding the value of x dash y dash, then the finding the value for x dash y dash is equal to transformation matrix into the x and y. Then we will get the value of x dash y dash. This is the formulation of transformation. Formulation of transformation means any transformation, in any transformation. Transformation having 5 types: rotation, scaling, mirror. In any transformation, transformation matrix is there, and multiplication of original matrices with the transformation matrices, you get the value for the new coordinates. Okay. Next, in transformation, first point is translation. Okay. First point is, first transformation is translation. Okay. In figure, you get the what is meant by translation. Point your line P1, P2 is translated to new location P1 dash, P2 dash. Original line is P1, P2, translate to new location P1 dash, P2 dash. Okay. If it is a translation, then point P1 is x1, y1, P2 is x2, y2. Then is translate to new location. It's a P1 dash is x1 dash, y1 dash, and P2 dash is x2 dash, y2 dash. Okay, p1 dash is p2 dash. Okay, if it is a translate, this line is translate by a distance. In x direction it is a tx, in y direction it is a ty. It is a translation value for this transformation. Okay, in x direction it is a tx, in y direction it is a ty. If we consider in 2D matrix, we consider the point P, x and y is translated in this line. Point P, x, y is translated to new coordinates. So P dash is the x dash, y dash. Then new coordinates of P dash, is equal to translation matrix plus original P matrix. Okay, translation matrix plus original P matrix. Then it's again x dash, y dash is equal to tx, ty plus x and y. Similarly for p1 dash it is, for p1 dash it is x1 dash, y1 dash is equal to tx, ty, x1, y1. Similarly for p2, x2 dash, y2 dash is equal to tx, ty, x2, y2. Okay, these are the new coordinates for this line p1 dash, p2 dash. Okay, we can go for next transformation. It's a rotation. Second type is rotation. Okay, in figure you see that the rotation having divided into 2 points. First one is rotation of point, means point P is rotated with the reference of origin to the new point P dash, and secondly it's a rotation of line. First one is rotation of point, second one is rotation of line. In this rotation, that figure, r is the constant distance from O, from origin point. Okay, from O, r is the constant distance. Then pi is the original position angle with the horizontal axis, is the x axis. Original positional angle with x axis means horizontal. Okay, then theta is the new rotational angle. Theta is the new rotational angle in counterclockwise. Clockwise is this direction, it's a clockwise. Counterclockwise is reverse to clock. Okay, it's a counterclockwise direction. Theta, new angle with original point. Or original location in counterclockwise direction. Okay, counterclockwise direction, CCD means counterclockwise direction. Okay, it's a rotational basic. Okay, then rotational matrices are cos theta, okay, minus sin theta, then sin theta and cos theta. Okay, it's a rotational matrix. For finding the new coordinates of P dash, it's a x dash, y dash. For finding the, we have a rotational matrix of cos theta minus sin theta, cos theta. Okay, go for next. Third type of transformation is the scaling. Okay, third type of transformation. In figure, we have to see that there is the original triangle P1, P2, P3 is scaled to P1 dash, P2 dash, P3 dash. Okay, original triangle is P1, P2, P3 is scaled to P1 dash, P2 dash, P3 dash. Okay, if we consider the scaling factor in x direction is a Sx. Scaling factor in x direction. Similarly, xy, Sy is a scaling factor in y direction. Scaling factor in y direction. Okay, scaling factor in x direction is Sx. In y direction is Sy. Then the new coordinates of point P1. Original coordinates of point P1 is x1, y1. Okay. The new coordinates of P1, it's a P1 dash is x1 dash, y1 dash. Okay. It's x1 dash is equal to Sx into x1. And y1 dash is xy into y1. If this value you can transform into the matrices, then scaling matrix S is Sx 0 0 Sy. Scaling matrix S is Sx 0 0 Sy. It's a scaling matrix. If scaling matrix is uniform, then uniform means Sx is equal to Sy. Scaling in both directions is same. Then it's again converted into Sx 0 0 Sx. Because Sx is equal to Sy. It's a uniform scaling. If it is a uniform scaling, scaling is in uniform. Uniform means same in both directions. Okay. Go for next. Transformation. Fourth type is reflection. Okay. Fourth type is reflection. But in reflection there are the 5 types. First one is reflection about the x-axis. Second one is reflection about y-axis. Third one is reflection about the origin. Fourth one is reflection about the line y is equal to x. And fifth one is reflection about the line y is equal to minus x. Okay, we go for one by one. First one is reflection about the x-axis. In diagram, we see that the reflection about the x-axis. The line P1, P2 is reflected about the x-axis, means a horizontal axis of P1 dash, P2 dash, reflection about the x-axis. We already know if it is reflected about the x-axis, then y coordinates become a negative, means y is negative. Then new coordinates, the new coordinates, for finding the new coordinates, the reflection matrix is mx is only y coordinate is negative 0 1. It's a 1 0 0 minus 1. Okay, reflection about the x axis, y coordinate is only negative. X coordinates is become same, y coordinates is negative. Then next one, reflection about the y axis. Diagram shows that reflection about the y axis. Similarly, reflection about the x axis. Only here reflection about the y axis means x become a negative. Then reflection about the y axis, y, x become negative. It means -1, 0, 0, 1. Reflection about the y axis. Only x become negative value. Other one is same. Third part is reflection about the origin. In diagram, we see that reflection about the origin. Point P x y is reflected about the origin, and get the point P dash is a x1 y1. Then x and y both are negative. X and y both are negative. In case of reflection about the origin, x and y both are in negative. Then reflection about the origin, MO is become -1, 0, 0, then -1. It's a transformation matrix for reflection about origin. Okay? For reflection about line y is equal to x, in diagram shows that one line P1, P2 is reflected about line x is equal to y or y is equal to x. This line reflected about the line y is equal to x or x is equal to y. Then if y is equal to x, the new coordinates of x dash become y and y dash become x, because x is equal to y or line is y is equal to x. Hence, if line is reflected about the line, reflection about the line y is equal to x, the new coordinates for finding the new coordinates, okay, matrices is m y is equal to x is equal to y x or y is equal to x is equal to 0, 1, 1, 0. Okay? Only reflection, but x dash become y, y dash become x. Therefore, here first is 0, then 1, 1, then 0. Means you can interchange the value of x and y because of line reflected about the line y is equal to x. Line P1, P2 is reflected about the line y is equal to x. Therefore, new matrices is m y axis 0, 1, 1, 0. Then next is reflection about the line y is equal to minus x. Reflection about the line y is equal to minus x. Again, in diagram, they will show that y is equal to minus x line. Reflection about the y is equal to minus x. Then, for y is equal to minus x, for y is equal to minus x, x dash become minus y and y dash becomes minus x. Okay? Y is equal to minus x, then x dash becomes minus y, y dash becomes minus x. Negative sign is applied with the interchange of x and y. Hence, new, for finding the new coordinate, matrices will be m y is equal to minus x is similarly same but in negative value 0, -1, -1, 0. This is the reflection. 1, 2, 3, 4, 5 types of reflection. Okay? Go for next. Okay. Again in shear there are two types of shear. First one is x direction. Second, y direction. Okay. First one is x direction shearing. Second one is y direction shearing. In figure here in x direction shearing you see that it's a original and next one is after shearing. Original before shear, new is after shear. The point it's a rectangular. The point is PXY is after shear is here become a P dash is a X dash Y dash, means before shearing, after shearing. If yes, HX is a shearing in X direction. In X direction shearing. Okay. For this finding the value of new coordinates, only X direction shearing, it's a P dash is X dash Y dash. Okay. X dash Y dash is for shearing in X direction. 1 SH X0 1 into the X 1 into XY. Therefore, shearing in X direction, it's a matrices is 1 SHX 0 1. It's a matrix for shearing in X direction. Okay, shearing in X direction. Similarly, if it is a shearing in Y direction, then yes, HY is Y direction shearing. Okay, shearing in Y direction. Is it okay? Then matrix for the finding the shearing in Y direction is matrix for finding shearing in Y direction is SHY is equal to the 1 0 SHY and 1. It is a matrix for finding the new coordinates if shearing in Y direction. It is if shearing in X direction. Okay. These are the 5 types of transformation, and we have to see that what are the transformation matrices about the all 5 types of transformation. Okay, go for next. Next in transformation is concatenated or composite transformation. Concatenated or composite transformation. Okay. Concatenated or composite transformation means you can transform one model in multiple transformation, means more than two or more than two transformation, means you can rotate the geometry and then reflected it about the x-axis, about the y-axis, and anything, or you can shift it in a direction then rotate it, means it is a combination of two or more transformation. It's called composite transformation or concatenated transformation. Okay, means you can mix up with two or more transformation. It's maybe rotation, it may be scaling, it may be reflection, it may be translation. Okay, for this term we have take one example. Okay, Consider point P, x, y. Okay, P's coordinate is x and y. Is to be transformed to the new position. Transform to the new position. P dash is a x dash, y dash. With by first it is a rotation. First it is a rotated. Okay. Second, scaling. Second one is scaling. Okay. First one is rotation. Second one is scaling. Okay. Then how you can calculate the new coordinates of x dash, y dash. New coordinate system of x dash, y dash means for point P dash, it's a first one is rotation, second one is scaling. Then you can take in multiplication, you can take in reverse direction. In second one is scaling, take a scaling matrices, then take a rotation matrices, and then last one is original point coordinates P. Means second is scaling, first one is rotation, but you can take here first is rotation, first one is scaling, second is rotation, then original point P. Okay, then it's become CT, composite transformation, and P. This is called as a matrix for composite transformation or concatenated transformation. CT is a new matrix and it is called as composite transformation or concatenated transformation. Concatenated transformation. Okay, CT. Okay, if you have to find out the CT matrices, CT is scaling, then rotation matrix. You know the scaling matrices is Sx 0 0 Sy. Okay, and in rotation matrices cos theta minus sin theta, then cos theta is the rotation matrices. Then CT becomes Sx cos theta. Okay, Sx cos theta minus Sx sin theta, Sy sin theta, Sy cos theta. It's a new matrix, composite matrix CT. Okay, this is called as composite transformation, and this is the matrix for composite transformation. This matrix is changing as per your combination. If it is a scaling then rotation, first one is rotation then scaling. If it is a reverse, first scaling then rotation, then R is here, S is here. Means rotation first then scaling. Okay. These are the formulation, all formulation about the transformation in 2D spaces. Okay. Thank you so much.